Thank you for joining us today for RCR Wireless's look at tower and antenna technology. I am Kelly Hill, technology reporter for RCR Wireless News, and I'm pleased to tell you that I'm joined today by Joe Madden, principal analyst with Mobile Experts, Christos Karmis, president of Mobilitie, and Dave Mayo, senior vice president of technology for T-Mobile US. In conjunction with this webinar, we are publishing today a tower and antenna technology special report that will be available post-webcast at www.rcrwireless.com. You can download this report at our website. This is a report that basically takes stock of the state of the industry in terms of tower and antenna technologies. There are two major network shifts occurring from voice to data and an outdoor usage to indoor usage, which has some major implications for the network. There are different trends going on in terms of site configuration with remote radio heads and fiber to the antenna, and the densification of the network in terms of small cells is definitely another hot topic right now. The report also looks at some of the concealment and tower safety issues that are present in the industry currently, as well as the use of more fiber at the tower, both in terms of connections and in terms of backhaul. And also examines how multi-band and multi-technology networks are driving some of the changes at the macro site. Some of the other issues that we get into in the report are overloading of towers and mounts, and some of the issues that are related to that. Indoor installations, and again, this relates back to network densification in terms of distributed antenna systems and small cells. And of course, when you bring up small cells, there are issues related to backhaul and power issues for urban densification. We also start talking about fitting more complex network equipment into a smaller footprint, and that goes for both indoor installations in terms of concealment, as well as outdoor macro installations. In terms of components, we take a brief look at those, some of the new things that are on the market, supporting things like better heat management and efficiency. And we also have a snapshot of each of the carriers' recent investments in terms of their infrastructure. And so with that, I'm going to ask Joe Madden to give us his presentation. We're going to start there with you, Joe, giving us a look at some of the major mobile infrastructure trends.
Okay, thank you, Kelly. It's good to be here, and let's go ahead and go to the next slide. Maybe the first thing I should do is introduce my company. Many people have not heard of Mobile Experts. We are a small market analysis firm. We publish research on base stations, small cells, including things that are specific regarding synchronization for networks or DAS, carrier Wi-Fi, Cloud RAN. Our approach is to hire analysts that are 20-year experts in each of these specific areas, and recently we've been looking very closely at this, the trends that you mentioned, Kelly, the transition from voice to data, what that means for moving from outdoor networks to indoor networks, and some of the slides that I'll show today are a high-level overview of what's happening in the macro network outdoors and in the towers and antennas themselves as we make this transition from voice to indoor data. So let's go ahead and go to the next slide. Some key questions for today. What's going on with macro base station deployments? What's the future outlook there? And what's the right balance between macro base stations and small cells? One of the things that we've done is to closely examine some of the densest mobile networks in the world in Seoul, Korea, in Tokyo, in Japan, where we have extremely high density of mobile data. And in those networks, the outdoor macro network is not enough. They absolutely have to use things like Wi-Fi and indoor small cells in order to get the kind of density that they're passing every day. Just a sort of a side note, here at the Super Bowl in the United States earlier this year, we had about 1.9 terabytes of data through one mobile operator. And so that turns into, when you calculate it out, it turns into a mobile density of about 0.1 gigabits per second per square kilometer per megahertz of spectrum. And that's a level of mobile density that we see almost every day in Tokyo. There are some really interesting cases out there which show us the future of what's going to happen in the rest of the world. Next slide, please. And this is one way to look at it. We're sort of tracking the capital spending by all the major operators around the world, and as we look at the future trend, we've had some ups and downs in the past few years, but if we map out the general direction of the next 5 years, what we can see is that the spending on macro base stations is holding up, but it's starting to come down a bit over the next 4 or 5 years, and at the same time, we're starting to replace some of that spending with small cells and DAS networks, which are adding significant capacity in building. Carrier Wi-Fi is another big piece of this, but I think that might come in from different sources of capital. We may see the MSOs deploying a lot of that, and especially in the United States, we may find that fixed wireless operators are going to act as wholesalers for the mobile operators and may save them some money on the capital side. So let's go to the next slide. We'll take a little closer look at what this means. One of the things we do is we map out all the different technologies that are options out there, and two of the axes that we look at are, how the technology supports mobility, soft handovers, and high vehicular speeds, and so on, versus fixed wireless, where someone is sitting still using a phone or a laptop or something like that. And then there are solutions that are well suited for coverage, and others that are well suited for capacity applications. And what we find is that the macro network has really been designed for mobility, obviously, and it's somewhat adaptable for either coverage or capacity applications. But as we get into these really dense networks where we need mobility and high capacity, then we start using things like outdoor small cells and low power remote radio heads with Cloud RAN. Well, at least for now, it's centralized RAN and leading toward Cloud RAN implementation in the future. And when we get into really fixed coverage applications, then we have things like consumer femtocells or Wi-Fi systems, even repeaters, which are very low-cost ways to get that wireless coverage and take care of people that are sitting still. And so this is one of the ways that we break it up and look at our forecast in different segments. Next slide, please. Taking a look at the macro base station deployment, it's pretty lumpy, and as we saw in the capital spending slide earlier, we had a good year in 2011 and a big drop going into 2012. We've got some strong deployment going on right now in China, which is creating another bubble of demand. But over time, we expect the number of base stations deployed on towers and rooftop sites and in these high-power outdoor sites to be declining. And there are multiple reasons for that. One is that many countries are slow in issuing new bands for LTE spectrum. It just takes a long time for that to happen. The other thing is that getting new towers erected is difficult. It's becoming more and more difficult all around the world. And so I think there's diminishing returns there. It's getting more expensive to do it, and the data's indoors anyway, so some of the money is starting to move to other purposes. Next slide, please. One thing I should point out is that we look at base stations, but we also look at the radio transceivers in the base stations. And despite the decline in the number of macro base stations, the radio transceivers that support them will actually be increasing over the next 5 years. One reason for that is we're going to higher order MIMO, and the way we count transceivers, 2x2 MIMO sector would have 2 transceivers and not 1. And that gets even more extreme when we talk about TD-LTE with 8-way phased array antennas, where then we would have 8 transceivers per sector. So the trend that we see in the macro equipment is moving toward fewer number of base stations, but each base station would have more radio content. It would have more complex radio infrastructure and a lot more antenna elements to be supported. Let's go to the next slide. Okay, and the other thing that we see when we talk about tower and antenna technology is that a lot of these base station deployments are moving active electronics up the tower. The early remote radio head deployment was often implemented with the electronics at the base of the tower in very long jumper cables. especially in the United States, where some of the operators had bad experiences with tower top electronics 15 or even 20 years ago. There's long memories that prevented some of these operators from jumping on that for this next generation. But we've worked through that, and some more recent deployments are starting to take advantage of the radio performance benefits you get from putting remote radio heads at the top of the tower. You know, you save all that weight of the coax cable, you get better signal to noise ratio, which results in better throughput and better range overall. And then we've also seen some integrated antenna radio products. Ericsson's product is the most well-known form of this, where the remote radio head and the antenna are integrated into the same physical enclosure, and that can be helpful in some cases to save some money when you're leasing space on the tower, and having one box is cheaper than two. But overall, that trend is not expected to go worldwide. One of the surprising things that we've found in studying the market is that during 2013, there were a whole lot of active antenna system transceivers shipped, 5 million last year, and so that's really a result of a very quick ramp in China with TD-LTE networks, and it's resulted in a lot of new learning in how we deploy these things, because these active antenna systems involve 8 transceivers in a sector, a big fat antenna panel which has 8 transmission cables coming up into the bottom of it, which causes some problems with weatherproofing and weight of the cables and integration and those kinds of things. So I think we'll see new innovations coming to integrate these things more and more, and try to, again, get rid of some of that weight and expense involved with the radio heads. Let's go to the next slide, and I'll try to wrap up and let the other guys talk. One of the things that we see is that the balance of mobile data traffic is going to shift. You know, up through about 2012 to 2013, it's really just been Wi-Fi and the macro network, and roughly half of the mobile data that's going in and out of your mobile device all around the world is either on the macro network or Wi-Fi networks right now. But as we go across the next 5 years of our forecast, our models show that the macro network really can't handle the kind of data growth that we expect to see. All the new applications that are coming and things are driving huge growth in the data traffic, but the macro networks, we're just not getting that much more spectrum and that much more capacity from densification of the macro. And so that brings in the small cells and DAS and carrier Wi-Fi and other scenarios, mostly in building, which would offload that data from the macro network and allow us to continue growing the capacity of our overall global mobile data network. One of the things that I've done, I don't have this chart in the presentation here, but I've actually mapped out how much of each of these segments goes through a DAS network. And you know, by 2018, our expectation is that somewhere between 10 and 20% of the total data traffic through mobile devices will be through some kind of a DAS network. It could be Wi-Fi connected to a DAS. It could be a small cell feeding a DAS. One of the things that we're seeing is that some of the new solutions that are coming out are bringing down the cost per bit dramatically. And I think in many of those cases, we can deploy those new signal sources together with an inexpensive DAS network and start to cover buildings that have never been covered before. So recently we've been talking about $100 billion in-building opportunity because there are really millions of buildings around the world that are not covered, and which could be if we had the right price point in some of the new equipment. So we believe in this growth trend. We see it continuing out through 2020, and we think that it's really going to be supported mostly by indoor deployment and some ongoing outdoor deployment. The last couple of slides, you can just click ahead to there, Kelly. The last couple of slides are about our methodology and just some contact information for our company. We can jump to the next one. So if anyone has questions, they can contact me at the email address shown there. And I think we're going to save our questions to the end. Is that right, Kelly?
We're going to save questions to the end. To our audience, if you would like to start submitting questions, please feel free. We would like to have some questions from you for our panelists to address at the end. So Joe, thanks so much. Great information there, and it's really interesting to hear that you get so much of the future traffic coming through DAS systems. That's some interesting information. Christos, we're going to go ahead and take over your section of the presentation, and then we'll come back to Dave.
Okay. Thank you, Kelly, and to the RCR folks for hosting this webinar. You can probably go ahead and jump to the, or actually before you jump to the next slide, let me just take a minute and I assume most people on the call are aware, but Mobilitie, we're essentially a wireless infrastructure firm. So we fund, own, and operate different wireless infrastructure across the country, of which that includes everything from communication towers to in-building DAS to outdoor DAS to small cell and Wi-Fi, and basically all different types of wireless infrastructure. Okay. And then I just have a few slides to walk through, and I'm happy to answer any questions towards the end. And you know, I think consistent with Joe's message around demand and where you know, how the wireless space is evolving, and how I'm sure everybody on this webinar understands what's happening in the space. If you really, you know, kind of step back from the noise, and it's difficult to do when we're all consumed with the details, but when you step back and you really look at what's going on, you know, this slide is one of my favorite ones here, where if you just look back as recently as 2009, and you just take like a concert, and you know, this one is a Bruce Springsteen concert, and I'm not as familiar with kind of the newer bands, but right, 2009, huge concert. When you look at the crowd, right, everybody's in the concert, and nobody has their phones out. And when you look at the crowd today, you know, pretty much everybody has their phone out. And you know, I don't go to a lot of concerts, but every time I do go to one, it's so shocking to see that, you know, more people are more consumed with recording video and taking pictures and sharing that on their phones with people in real time, almost than they are, you know, and actually watching a lot of the events. And even when you watch events on TV, a lot of times, right, if you take the time to look at what the audience is doing, I mean, you really notice everybody is literally on their phone. And so when you kind of just step back from the numbers and you look around at just fundamentally what's happening, it's pretty amazing. And it's really amazing when you think that, you know, it wasn't that long ago when, you know, nobody had their phones out and were doing any of this. So just huge growth, as everybody here is aware. But a lot of this type of consumer behavior is really what has been driving the requirement to kind of build out these high capacity DAS networks in the largest venues. So that's, you know, just kind of fundamentally what's happening, separate from the actual analytics. Okay, and then on the next page, if you page down one more, obviously from a demand on the wireless network perspective, it's also further exacerbated when you look at all the different activities and drivers that are out there in the industry. You have the whole social aspect, where everybody, you know, is taking videos regardless of where they are in pictures and sharing those. All the Facebook, YouTube, you know, all those types of activities that are very taxing on the wireless networks, but it's what everybody's doing, and it's certainly what all the younger, you know, generation's doing. And then when you look at separately, just all the different mobile applications that are out there, from, you know, all the in-venue experience applications to, you know, the ones that the Ubers of the world, and, you know, even all the social gaming mobile applications, right? You're pretty much online and communicating, you know, while you're running those applications. And so it's just been a huge driver, you know, in terms of wireless demand. And we haven't really seen the effects yet, I don't think, from the other categories, right? There's the whole wearables piece that is kind of new. Everybody's still, I think, trying to figure out, right, what really is viable and what's not. You know, I just look around and you see how many people are wearing Fitbit devices and you know, all these types of wearables, and it'll be a huge piece of the market, and they're all communicating either back with somebody's phone that's uploading somewhere or on the wireless networks. And then in addition to that, you have all the other connected device markets. So there's really, when you look at it, we're still very much, you know, at least in my opinion, in the infancy stage of where kind of the real demand is going in terms of, you know, the amount of data being transmitted on the wireless networks. And if Kelly, if you page down one more. And so from our perspective as a wireless infrastructure firm, right, we obviously kind of track and understand, you know, what's happening in the industry, but really when you pare it down and you say how does that impact us as an infrastructure firm, and kind of the simple answer is, our role is really to support, whatever's required on the infrastructure to enable, higher speeds and higher capacity on the wireless networks. And really what's happening is you need additional broadcast locations, a significant amount of additional locations to transmit, and everything has to be closer to the handset. So that obviously has a big implication in terms of the additional infrastructure that's required. And then when you kind of look at the macro network, so obviously there's additional tower and sort of macro build associated with that, whether it's new towers or co-locations and rooftops. And as Joe mentioned, it's becoming more difficult every year to build new tower sites, but certainly there's a large densification of just the macro network separate from DAS and small cell. And then when you look at all the in-venue experience of the higher capacity venues, certainly the DAS market, everybody is aware of kind of what's happening there, but there's still, a large requirement to continue to build out DAS networks at the larger venues as well as to upgrade existing networks, because, it doesn't take very long the way the data demand is growing for existing networks and networks that are only a few years old to essentially become outdated. And then the other element is with the advent of small cell, which is still in the infancy stage. Obviously, it's really kind of understanding, what are those implications down the road, and how does that come in to improve coverage quality and capacity of the wireless networks. And then I think kind of the last point here around Wi-Fi is really, how does Wi-Fi also augment the wireless networks, and what's the carrier's role? What's our role as a neutral host? What's the venue's role with Wi-Fi? There's a lot of different models looking at what's the right way to basically fund, install, and operate these Wi-Fi networks, and what's the right model? Who's really the beneficiary of that, and how does all of that work? And it's still relatively in the infancy stage, as well as just from a pretty basic offload of carrier networks through auto authentication on the Wi-Fi. So that's very early on as well, but certainly it'll be a big piece of what's coming down the pipeline. Okay, and if you page down one more. So on just kind of a few points maybe to make on the tower and the macro side here. Obviously, the number of locations are going to continue to grow as the networks need to densify further. One of the added complications I think on the macro side, at least that we've seen in working with the carriers, is as the cell locations sort of shrink in size, and as you look at cell splitting and sort of other activities that happen, the level of precision around the RF engineering for which locations work, which heights do you need, how does it hand off to other sites, what's going to be the overlay with small cell. The RF engineering piece is becoming much more particular in terms of ensuring that the network works properly. So that's becoming more complex. Obviously, as remote radio heads and other equipment are mounted on the towers, there's additional sort of factors there to be thinking about. It makes a lot of sense. You have to think about obviously servicing of those equipments on the tower. Backhaul is, I would say, one of the other areas where there's a large percentage of sites that you can bring, or that either already have fiber to the site, or you can bring fiber, or a good alternative backhaul solution. There's also still a lot of sites out there that don't have the type of backhaul that they should have, given where those sites are located and the cost to bring a more robust backhaul solution to that site. So that's going to continue to be a challenge that needs to get looked at as time goes on the sites that still need to be upgraded. But the other big trend, just from our perspective in terms of the build out of new infrastructure, has been really the zoning and permitting process required to get sites permitted, and that continues to become more challenging every year. The level of stealthing and concealment continues to increase every year, even in locations where you wouldn't expect that to happen. Obviously, we have a lot of experience building different types of stealth structures, and we included some photos here, but everything from rocks to clock towers to windmills, and we have, I'm sure, a very large and robust collection of different types of trees and other structures as well. So that's becoming more and more challenging every year, because it not only adds cost to the process, but it also can limit what you can install at that location. It makes servicing of the tower more complex just from a safety perspective as well. And so there's a lot of factors that come along with the implications applications around stealthing on the towers. Okay. Next page, Kelly. When you look at the DAS infrastructure, I mean, some of the trends that we're seeing in DAS, and we're very active in the DAS space, obviously, but all the venues that we're talking to, there's a large preference for a neutral host type model where venues don't want multiple different systems installed, and so we spend a lot of time to design the right neutral host model that's accounted for multiple carriers as well. So that's obviously a trend everybody kind of knows about, but certainly that's becoming bigger and bigger as more and more venues, I think, begin to understand the space. On the hardware side, we're technology agnostic in terms of different hardware. One of the trends certainly is, and it's different OEMs are at different points, but certainly kind of bringing fiber to the antenna or closer to the antennas is a trend that everybody's looking at right now. On the carrier perspective, we spend a lot of time around the design of the networks and ensuring that they're designed for speed and capacity, and not just today's capacity, but capacity that's expected in the future. So there's a whole effort around that. There's a lot of complexity around also ensuring the design is appropriate for the transition zone planning with the macro network, especially when you're balancing multiple different carrier requirements. And then one of the other aspects that has become, I think, more prevalent as well is a lot of input from the venues themselves. And what you really have happening is, venues are understanding kind of the networks better. They're wanting to, and they're wanting to not just have a DAS so that the carriers can have better service, but they want to have a DAS so that their customers essentially have better service, and they view it as a negative against the venue when you're there and you can't connect. So they're very concerned to ensure that when people are at the venue, their mobile phones work properly. And it's further compounded because especially in some of the sporting and entertainment venues where people want to roll out what we call the venue experience application. So whether it's the At the Ballpark app for MLB, or whether it's any of the other mobile apps that can, whether it's video, being able to broadcast video or other features, most of those big venues now want to roll out some type of mobile application to people to be able to use while they're on site. And so a lot of that also requires that the network's designed to accommodate that as well. So they're becoming much more involved in terms of the design standards. And then, Kelly, if you flip back one page, maybe kind of the last point to make on this page here is just around overall concealment and stealthing of antennas and equipment. And we spent a lot of time with venues, especially kind of given the uniqueness of a lot of these venues and the importance of the venue to them, to ensure that we stealthed antennas and equipment so that they're not obtrusive. And we installed and operate the DAS at Arrowhead Stadium, and that's probably one of the better examples in the industry of stealthing. We replaced all the section headers there on that picture where it says section 341 and 342. We basically replaced that with a faux section header, and there's remote units mounted inside there. It looks exactly the way it did before. It's, I think, only slightly larger, but unnoticeably larger. So there's a lot of effort that's required to kind of stealth things properly, and balancing keeping the venues happy as well as all these types of things at cost and complexity as well. And then maybe one of the other interesting elements at Arrowhead Stadium that we did was for field level coverage. For people on the sidelines, or also when they have concerts there's antennas mounted behind the padding that's at field level. And so we basically replaced the padding. There's antennas mounted behind there, and so you can't really see them unless you remove the padding. But I don't know. We don't know of any other stadium that's done something like that. But it's certainly a lot of ongoing work with the venue to ensure that they're also pleased with the systems as well. Okay, so that's the Arrowhead network. The next page, Kelly, if you go down one more page, just around Churchill Downs. This is one of the other networks that we just completed. We actually completed it last year, and then we did a further permanent expansion to cover the infield prior to the race this year. And this is a massive venue. There's, I think, there's 165,000 people there for the Derby. I think we set the record for the total amount of data transmitted over a DAS network in the country during the event. It's also kind of another sort of example where you can't just come in and put in a system. You know, it's relatively complex when you really start to look at this and say, right, the transition zone area is extremely large. There's you know, high density of seating within the venue. There's also the nature of what they call temporary or you know, kind of reconfigured seating locations as well. So every year they put up temporary structures. They sort of modify the location of the certain suites, you know, every year. So we really had to design the network to accommodate that and be able to sort of reconfigure it every year, depending on, you know, kind of the details around the configuration for the event that year, but also factoring in, you know, just the business as usual or kind of the daily structure that's there for, you know, other events other than just the Derby. So that's, you know, probably one. This is, I think it's a 50 sector design. When we were done with this, you know, massive head end space, you know, a lot of, you know, HVAC considerations for systems that are that big as well. And it's also further complicated because the crowd flow pattern separate from the seating areas changes a lot every year as well. I mean, people are generally pretty mobile at the track here, so we've had to sort of contemplate different crowd flow patterns. And certainly last year, you know, it rained a lot, and the traffic flow at the Derby was quite different than it was this year when it was sunny. So there's a lot of event-specific factors that need to be taken into account into the design, and then just ongoing operations and working with these venues as well. Okay. Kelly, you can just page down one more. So that's on the DAS space, on the small cell and Wi-Fi space, and I'll kind of, I think, finish up here with this slide just to maybe explain kind of what we're seeing here. On the small cell, obviously, you know, kind of small cell deployments are currently underway, still in the early stages of, you know, hardware, of, you know, migration from narrowband to more broadband antennas. Certainly, you know, the big challenge everybody's trying to address is, you know, essentially the unit cost of deploying the small cell networks, and really trying to figure out how do you get the price point down to where it economically needs to be, and thinking through things such as just kind of the lease rights or attachment rights to install a node somewhere, you know, getting power to that site, getting backhaul to that location. You know, there's a lot of complexities around that. But for the small cell model to work, right, it's all at the end of the day really about requiring a very low unit cost given the broadcast radius of a small cell and given the volume of nodes that are intended to be deployed. So that'll be, you know, a space that continues to evolve. Obviously, as that further matures, the expectation would be the unit cost will, you know, come down over time. But certainly that's one of the big challenges on the small cell front. And then Wi-Fi is an interesting one. You know, certainly not all networks are created equal, as everybody knows, but certainly that's also the case with Wi-Fi. You know, there's a big difference between, you know, Wi-Fi designed as an internet gateway and Wi-Fi that's designed, you know, as a high-density carrier-grade broadcast Wi-Fi network. So we're really kind of understanding, you know, what's the right Wi-Fi design for the particular venue. How does that, from a venue's perspective, it's really about, you know, how do they leverage the Wi-Fi to integrate now more with their CRM type of activity. So they're becoming less concerned with the internet gateway and more concerned with how do I utilize the Wi-Fi network to have a better relationship basically with who's at my venue, whether it's messages or promotions that they want to provide to people, whether it's just understanding who's physically, you know, at that location, you know, who's new, who's somebody recurring. How does that integrate with their loyalty program if it's a type of venue that has a loyalty program? And so you really end up with, you know, Wi-Fi networks that the intent is, you know, a very robust Wi-Fi design that the venues have an ability to really integrate with their CRM and strategy and customer data. It's becoming less, I think, about third-party, you know, advertising and marketing and those types of things. It's really more about the venue experience. And then the other piece is eventually, you know, how does that develop into the carrier offload, and how does the carrier start to utilize that to auto-authenticate people onto the Wi-Fi network, and what's the right model in terms of, you know, do I stay on the carrier network or do I migrate to the Wi-Fi network? You know, what's better, what's cheaper? And with Wi-Fi, it's also about, you know, who's essentially at the end of the day subsidizing the Wi-Fi cost, and, you know, maybe depending on who you talk to, right, there's different opinions there in terms of who should be fronting CAPEX and the recurring OPEX for Wi-Fi networks between, the venue itself, between the operator, between advertising. There's, interesting, I think, maturation of that space to understand, how does that model really work and what does that look like on a go-forward basis that's also relatively immature, but will obviously kind of be a growing piece, as networks further develop and as it's really kind of required to provide, the data offload that it can do. So those are really kind of the trends that we're seeing, and we're spending kind of most of our time right now and most active in the DAS space still, but obviously that's as small cell takes off, as Wi-Fi is different, we'll continue to invest and be active in those spaces, in addition to the tower and the macro infrastructure.
Okay, great. Christos, thank you so much. Great. So Dave Mayo, Senior Vice President of Technology for T-Mobile US.
Great, Kelly. Thanks very much, and greetings from a mostly sunny day in Seattle. I've got 4 slides that I want to walk through. The first couple we'll talk a little bit about the T-Mobile business broadly, and the second 2 I'll share some more network-centric or network-specific information. So Kelly, if you want to hit the forward. So over the course of the last year, we've introduced simplified, unlimited, simple choice service plans that contain no annual service contract. We've also given customers the ability to subscribe to wireless service without the purchase of a handset, while at the same time introducing equipment installment plans to help credit-qualified customers who need a new device pay for them over a 24-month period. Next, we launched Uncarrier 2. It gave customers the ability to upgrade their handsets more frequently. Uncarrier 3 consists of simple choice for business and includes unlimited data and texting worldwide in over 120 countries at no extra charge. Additionally, we rolled out Uncarrier 3.1, which offers tablets with users 200 megabits of free data per month. This is a great product for any of those international business travelers on the phone. Most recently, we've introduced Uncarrier 4.0, which gives individuals and families the freedom to move to T-Mobile, as will reimburse early termination fees when they trade in eligible devices. So at T-Mobile, we're simply all about addressing those pain points that we as wireless customers have detested for years. Stay tuned, there's a lot more coming. Want to advance? So customers love what we are doing and have reacted favorably. In the past year, we've added 6.1 million customers, and our blended churn rate in the first quarter was a historic low for us at 1.5%. This is a 40 basis point reduction over the first quarter of 2013. So now for the more network-centric information. On the next slide, Kelly, thank you. We've been busy in the last couple of years since the proposed AT&T acquisition was abandoned in late 2011. In early 2012, we kicked off a program to modernize over 35,000 sites in the network. The modernization program consisted of 3 key elements. First, we upgraded GSM electronics, and in most cases, we moved the radios close to the antennas to eliminate coax losses, much as Joe described in his presentation. This has resulted in better coverage for our customers, and we see it in the results. Second is we've rolled out UMTS in the PCS 1900 frequency band, thereby refarming spectrum that was previously used for GSM. Third, we rolled out LTE in the AWS frequency band at an epic rate. In connection with the modernization program, we have used remote radio heads and integrated antennas in about 75% of the upgrades. Both of these solutions locate radios close to the antennas, minimizing coax losses and maximizing coverage gains for our customers. To date, we've completed over 30,000 cell site upgrades and expect to complete the program this year. In addition to the network modernization program, we'll begin rolling out LTE to the more rural parts of the network this year by utilizing the PCS 1900 frequency band. In total, we expect to cover more than 250 million POPs of LTE by the end of the year. Both the network modernization program and our rolling out LTE to rural areas is predicated on our having high-speed backhaul to our cell sites. We started working the high-speed backhaul problem several years ago and have rolled out high-speed backhaul to over 35,000 sites and contracted for another 10,000 sites, most of which we expect to be delivered in 2014. Kelly?
Okay.
Based on crowdsourced data, we have the fastest 4G LTE network in the U.S. Our LTE rollout now reaches over 220 million POPs in 284 metropolitan areas, including 95 of the top 100 metropolitan areas in the country. We've deployed 10 by 10 LTE in 43 of the top 50 metropolitan areas, and we are live with 20 by 20 in a couple of markets. We'll continue to commit more spectrum to LTE as we move traffic to the PCS 1900 frequency band and as we migrate Metro PCS customers onto the T-Mobile network and reuse that spectrum. We are ecstatic to finally have some low-band spectrum in our portfolio. You can hear it in my voice. The 700 megahertz licenses that we recently acquired from Verizon have great in-building propagation characteristics. Our 700 portfolio now extends to over 70% of our customer base. We plan to deploy 700 megahertz, both antennas and electronics, this year, and intend to have 700 capable handsets in our portfolio later this year. That's what I have, Kelly.
Okay, great. Some really impressive numbers there in terms of that deployment. So we're going to move on to the question and answers section of our webinar now and take a few minutes here to answer some questions, both from our participants and a few questions that I have, or I'm sorry, both from our webinar participants and a few questions that I have for our panelists. Dave, I want to start with you. You mentioned specifically that T-Mobile is going to be deploying LTE in the PCS 1900 for rural areas. Is there a particular reason that you decided on that band for that situation, and why not use AWS?
The rollout in the PCS frequencies is really easy for us, and by that I mean all we really have to do is change out the electronics at the base of the tower. We'll upgrade the GSM electronics at the same time that we roll out LTE, making for our being able to deploy LTE across rural America at a pretty brisk rate.
Okay. Great. We have some questions from our audience, and one of them was, and this one was specifically for Joe, but I think Christos, you might have some opinion on this as well. And that was a question from William on how do you see private and carrier Wi-Fi networks coexisting?
Well, maybe I should start by just defining what I was showing in that chart. Is that, you know, in my mind, private Wi-Fi networks are either a corporate IT LAN or you know, your home Wi-Fi, and I think that the difference is that the carrier Wi-Fi networks are going to be more or less geared over the next few years. They'll be converting over to the Hotspot 2.0 authentication to make it more seamless for people as they walk into the Starbucks or the airport or whatever. And they're, as someone mentioned, they're going to have to be subsidized, whereas the private Wi-Fi networks are something you buy and plug into your own broadband.
Mm. Okay. Okay.
Yeah, and maybe this is Christos. Maybe just to also elaborate one other point there. I mean, we also sometimes look at it distinctively different with a back of house and sort of front of house Wi-Fi network, to where some venues want a much more secure and separate back of house Wi-Fi that isn't necessarily leveraging a lot of the same hardware and integration with what they would consider their front of house or public Wi-Fi that's designed to be the guest-facing Wi-Fi network. Feeling like that, you know, if they're running on the back of house network, kind of their critical operational type items, that they want to keep that separate from just kind of users logging in, mostly from a security perspective. So that's kind of one of the trends that we see.
Okay. Christos, I think this is a question specifically on some of the or on one of the installations that that you referenced from Mobilitie, and asking if there are RF safety and emissions issues with installing antennas at field level where people might be able to walk in front of them. How did you address that?
Yeah, good question. So like in that example at Arrowhead Stadium, the antennas that are mounted behind the padding, those are actually only turned on during certain events. And so I think, the team's kind of factored in all the safety requirements and for certain events, and I think those are mostly driven by like concerts where there's additional kind of separation around the antennas that may not exist when somebody's like walking directly in front of it. So I know they kind of looked at sort of different use cases for those antennas, and they're actually the ones on the field level are ones that are actually not necessarily permanently on all the time, but can be basically turned on demand when there's an event that requires that.
Okay. We did have a question about whether the slides for today are going to be sent out to participants. The answer to that question is yes, they will. And so let's move on to a couple of other questions. Dave, this one's for you. How is the Metro PCS migration going?
It's going great. It's going exactly as we planned it to. When we first announced the Metro PCS acquisition, there were a lot of parallels made to Sprint and Nextel, and frankly, we've been very successful at migrating the Metro PCS customer base, and have migrated over 60% of that base onto the T-Mobile network, and in fact are planning to turn off 3 of the markets this year, as was talked about in the earnings call this quarter. So it's actually going really well. One thing I'll address another one, if I might, while I'm here, and that's somebody asked about Uncarrier. And Uncarrier is all about trying to solve customer pain points. Every major program that we've released or launched over the course of the last 15 or so months has really focused around trying to solve a customer pain point. And you can put money on John Ledger, our CEO, wanting to tackle more of those pain points over the coming quarters.
Okay, great. So let's see. Let's look through some of the other questions here. Mobility. Christos, this one is for you. You mentioned increased leasing challenges for small cell deployments. I'm wondering if you could, and we had a question on whether you could expand on that a little bit in terms of maybe give us a better idea of what you see happening there.
Yeah, I mean, I think just at a high level, right, there's for every site, there's some portion of cost related to site acquisition and obtaining kind of the rights to actually install something at a particular location. And that kind of comes in 2 facets, I think. One, it comes from the actual services related work to go secure the rights to be there, and then it can also come in the form of the recurring cost, whether it's a lease or some other type of cost to physically be able to be at that location. Especially if you look at like an outdoor small cell scenario. I mean, it's obviously different if you're installing small cells to support like an enterprise client that you're just kind of putting it in a facility where you don't necessarily need sort of separate rights to be there, that you can kind of quickly and easily and cheaply be there. But when you start to look at especially like the outdoor space, there's some cost associated with doing the site X services work to be there, and then additional costs associated with actually maintaining an installation at a particular location. So essentially those costs that there could be a relatively small percent of like a macro tower site, but the question becomes what percentage of the tolerable small cell cost is associated with that, and how do you drive that cost down to where you can make it economically more feasible.
Joe, I'm wondering if you can help us out here with a little bit of an insight on what you see in terms of happening with the emergence of TD-LTE.
Well, I think TD-LTE changes a lot of things because of the nature of the system. I mean, first of all, the implementation that's happened so far in places like Japan and China has used these active antenna systems, And as we start to look at putting those up on towers, we're looking at much bigger antennas. They're the sort of flat panel size antennas as opposed to the skinny 2-meter tall antennas. And one of the things that does is it increases the weight. There's a lot more coaxial cable. There's a larger antenna. It takes more space on the tower. I think that could impact just about everybody that's involved, including the operator. Like, for example, Sprint might be the one to do it here in the United States, but that could impact the other operators as well as they start to hog more room on the tower. And it could change the economics for the tower operators as well. When we start to go to DAS and in-building and small cell networks, it starts to create some interesting interference scenarios. The DAS networks for TD-LTE and FTD-LTE might need to be designed somewhat differently to protect these things and keep the interference, keep the signals separate. And so I think it's just another wrinkle of technology that we're going to have to deal with. And there's nothing insurmountable here, but it's another thing that we're going to have to design into the networks along the way.
Okay. A follow-up question on that one, since you mentioned the active antenna systems. We had a question on the 5 million that were shipped in 2013, and a little bit asking for some clarification on who the suppliers are, and that Ericsson being a major player with Air, and whether they're the major supplier for Chinese deployments. Huawei, can you give us any insight in terms of what the mix is there?
Yeah, I mean, it's mostly Huawei and ZTE and actually a couple other Chinese suppliers that are taking the bulk of that business so far. China Mobile is by far the biggest deployment of TD-LTE networks. Ericsson is well known for having the integrated antenna radio product, but I want to be clear that I don't consider that an active antenna system.
Okay.
That's integrated antenna radio is one thing. That's physically combining these two boxes into one box. But an active antenna system has some electronic beam steering involved with it, and in fact, that's done in these TD-LTE systems without integrating the radio head and the antenna, because if you did that, you'd have this giant 400-pound box that you couldn't get up the tower.
Okay, good to know. We had someone ask if there will be a downloadable version of the webinar. The answer is yes. That should be available, I think, within about an hour or so after the presentation is concluded, and that will be available on the RCR website, which again is www.rcrwireless.com. We are getting to the end here, gentlemen. I apologize that we couldn't get all of the questions answered. We had some great ones. But I'm going to ask each of you to give us one final look forward, now that we've kind of covered where we're at. And if each of you could tell us what you think will be the major trend that influences tower and antenna technologies in 2014, this year. Who wants to start?
I can start. Joe Madden here. So, one of the trends that I'm anticipating and have been doing a lot of research on is this migration from outdoor macro networks to indoor networks, and I think as we make that transition, some of the business models will change. For 25 years, at least since I've been involved in this market, all the money always comes from the operators. So the operators have to fund everything, and it's been nice growth along the way, but we're now reaching a point where people want more data, and the operators aren't making that much more revenue. So the data growth curve is steep, and the revenue growth curve is pretty shallow. And so I think in order to continue the growth, we have to start looking for different sources of capital. And I think as we move to these in-building solutions, we'll start to see the enterprises and neutral hosts and building owners starting to step up and funding some of these systems, much in the way that Mobilitie does. But I think many other companies will come out of the woodwork to start to support some of these things, and enterprises are going to ask for that so that they can get better coverage for apps for their business.
That probably sounds good, Dave, right? More people paying for network improvements. Dave, do you have insight on what you see as a major trend for this year?
Yeah, I think I'd boil it down to, in the near term, kind of three things, and there, within one of them, there's three things. So I have to call out video because that's what's driving the insatiable demand for data and the load on the networks. And with that data, that video is going to be a requirement for ubiquitous coverage. So I think that's kind of the need set, and the solution set in my head is two things. It's one, it's more spectrum. The industry, particularly relative to other economies and the other industrialized economies in the world, is short on spectrum. So we need more, and it looks like there's things in the works, and we'll hear more tomorrow, that will provide more spectrum to the industry. And third is small cells, which I didn't touch on in my presentation. At T-Mobile, we've really focused on modernizing the network in the last couple of years, and we've got an ample near-term spectrum portfolio to support our customer requirements. So we haven't had the same urgency that some of the other operators have had to rush to the small cell solution with. So I think small cells will play an important part over the coming, kind of the midterm. And in conjunction with small cells, I think there's really three dimensions to it. It's that frankly both Joe and Christos mentioned, and that's one is the RF planning dimension to it and how the small cell environment interacts with the macro network. Two is the siting dimension and how siting is going to work in a world where the industry is used to deploying big cell sites, spending lots of money, too much money, getting through the entitlement process, and you really can't scale that to deploy tens of thousands of units on an annual basis. And then third is linking up the backhaul to support those nodes as they're deployed. I think it's really those three big topics, and then the three within small cells that are going to be, I think, a big challenge for the industry in the near term.
Okay, great. Christos, your perspective on 2014?
Yeah, for 2014, we still see obviously kind of the major focus being the ongoing sort of DAS build-outs that we have in process. I think 2015 is really kind of the small cell kind of the year of small cells. I think, but what will happen in 2014, and I think kind of just probably echoing what Dave mentioned, is really kind of what's the real kind of viability and structure around kind of small cells, as kind of the deployment ramps in 2015, and understanding where are those feasible solutions, and where is it just not feasible given the ability to put up a site cheaply, given sort of solving a backhaul solution, getting rights to power to be there. So really kind of working through out of the 10,000 small cell locations that somebody may want, how do you get down to what subset of that is actually feasible to go deploy, and what does that subset look like? I think that'll start to be flushed out in 2014, and then we'll kind of see the results of that essentially in 2015. I think the other part technically too is just to maybe better understand. Part of that is probably figuring out where they're feasible, right? Is the real benefit around small cell, right? Is it a capacity play, or is it more kind of coverage quality types of solutions as well? I think kind of that network solution, as well as kind of the big cost piece, is what you will start to kind of get flushed out this year, and then but we won't really kind of see the effects until 2015. But for us in 2014, the focus is largely ongoing DAS build-outs, just given what's in process today.
Okay, great. We've been talking today with Christos Karmis, President of Mobilitie, Joe Madden, Principal Analyst at Mobile Experts, and Dave Mayo, Senior Vice President of Technology for T-Mobile US. Thank you, gentlemen, and thank you all for joining us today.
Thank you.
Thanks, Kelly.